So in last lecture, we saw the difference between fusion and what are the nuclear energy, what it means and how we get that energy. Okay, so generally there are two reactions, nuclear reactions, to which we can uh, get the energy. The first one that is the fission. Fission means splitting the heavy molecules into the two lighter molecules, and the remaining whatever the mass imbalance is there, that mass will be directly converted into the heat energy, or we can say the energy. And another is the fusion. Fusion, as name indicates, we fuse two lightweight molecules and produce one heavyweight molecule. So during that also, whatever the mass imbalance is there, it will causes, or that mass will be directly changes into the energy. So that's how we will get the energy. Now that energy in the form of heat, and that heat energy we are using to convert the water into the steam, and that high pressure, high temperature steam we again use it to uh, uh, rotate the turbine. Okay, steam turbine. So that's how we will get the energy. Now the details regarding that we are going to see. So whenever any nuclear power plant is there, if there any nuclear power plant, there are uh, some basic components are there. So particularly, you will see this one is the nuclear core, okay, and this is the one schematic of the nuclear power plant. Generally, if you saw, only the heating part of that particular means steam generation part is only going to be changed. Other components like the heat exchanger, it may be a heat exchanger or it may be a turbine, all those are the same one. Okay, so this one is the better visualized. So instead of boiler, we are using the nuclear power plant. Okay, and instead of this simple fuel, we are using nuclear fuel to create that high pressure, high temperature steam. Okay, so you will see here, there will be a steam turbine, then the condenser is there. After condenser, it will pass to the or pump through the this particular nuclear core, and again the nuclear core heat will be generated, and that heat will be used to generate the high pressure, high temperature steam. Now, so this heat energy we will got, it is got from the nuclear reaction, and generally we are using fission reaction in the nuclear power plant all over across the globe, because we cannot able to find out, or we can say, to generate the fusion reaction on Earth till now. Okay, so you will see this one is the nuclear core, that is the part of the boiler we generally say. So you will see these are the fuel rods, orange color, those are the fuel rods in which we are using the enriched uranium 235. This one is the control rods, which is controls the reaction of the nuclear reaction. Because if you saw the difference between the nuclear bomb and the nuclear reactor, that in nuclear reactor, whatever the chain reaction is there, it is in the control manner. Okay, we are controlling that particular chain reaction. Whereas in the nuclear bomb, that chain reaction is not controllable. It is uncontrollable, and because of that, what will happen in very small time, small amount of time, there is a large energy will be generated. Okay, because of the chain reaction, and that will cause the explosion. So that is the difference between the nuclear power plant or the nuclear core and what we can say as the nuclear bomb. Okay, so similarly here, this control rod as well as the moderator, which is used to control the reaction, control the chain reaction. So as we know, in particularly nuclear fission, what will happen? There will be a one particular heavy element. Okay, generally it is uranium 235. Okay, it is the enriched element or the enriched uranium. Okay. Now it is the unstable at this particular state when it's having the mass 235. It is unstable. So whenever we strike one neutron, which is a neutral particle, okay, right? When we strike one neutron on this particular uh, uranium 235, it will split up. Okay. This particular uranium will split up into the two lighter weight nucleus. Okay, it may be a thorium, one is the thorium, another is the radium. Okay, and it is also gives C neutrons, small neutrons. It will also emit the neutrons. Okay, now these lighter molecules are stable at that particular point, but these neutrons will be again strike another three uranium nucleus or the atom. Okay, and that's how the chain reaction will be go fast. And that's how, because of that, what will happen, whatever the mass imbalance between this first reaction, if you saw here, there is a small mass will be directly converted into the energy by using the Albert Einstein equation E is equal to mc square. You can directly calculate how much energy will be generated if we totally convert all that particular mass energy. Okay, so totally convert that mass into the energy, heat energy. Okay, so when this reaction will take place, in each and every reaction, nearly 13.6 mega electron volts of energy will be generated. Okay, it is very small for a small amount of energy, but because of there is chain reaction, and those reactions will carried out in very small particular time. Okay, over very small time period, and because of that, you will see the large amount of energy will be generated, or we can say the large amount of heat will be generated per second. Okay, so because of that, what will happen, whatever the moderator, as a moderator also we are using water. Okay, and that heat energy will be absorbed by this particular moderator means it is a fluid, or it is particular component which are used to absorb these particular neutrons, or speed down this particular speed of the neutrons. Okay, because this control law, or the function of control rod to absorb these neutrons, and function of moderator is to reduce the speed of the neutrons. Okay, so just consider the understand the difference between the function of moderator and function of control rod. Control rod will directly absorb the neutrons, whereas the moderator will speed down the, or we can say it will reduce the speed of neutrons. Means it will reduce the speed of chain reaction. Okay, and if you want to close this particular power plant, we just insert this control rod, and these control rods will absorb this excessive neutrons, and that's how these particular chain reaction will be stopped. Okay, and another point is that, or another component we are using, that is the coolant. Now, why this is required coolant? Whatever the heat energy generated here, they have to transfer it to the steam turbine, right? Or another secondary cycle. So that heat energy, or we have to maintain the temperature of this particular nuclear core, under the safe condition. Okay, under the safe particular level. And for that, we are using coolant generally, and in most of the nuclear power plants, we are using water as a coolant. In some nuclear power plants, we are using sodium or sodium chloride as a particular coolant also. Okay, so now if you consider the water is as a coolant medium, it will absorb the energy, it will maintain the temperature of the nuclear core under the safe level, and this energy which is absorbed by the water, which is carried out or just forwarded to the secondary cycle. So in the secondary cycle, you will see this water will be traveled to the heat exchanger. In heat exchanger, they these particular water which directly came in contact with the nuclear rod. It will exchange the energy, exchange the heat to the second circuit of the water. Okay, so here the steam will be generated. Now this steam will be directly going to the turbine. Okay, and it will expanded in the turbine, and power will be generated. Okay, so there are different types of the nuclear reactors or the nuclear power plant in which different types of the cycles are used. Okay, and the water which is coming in contact with the nuclear rods, which is generally called as a heavy water, because it is generally it is in the pressurized form. Right? Okay, it's having very high pressure to maintain or to increase its saturation temperature, or to increase its boiler point. Okay, boiling point. Okay, so these are the elements. First one is to fuel rod. Then second one is the control rod. Third one is the moderator. Fourth one is the coolant medium, and then this particular casing. Okay, so that is the main component of the nuclear reactor, or we can say the nuclear core. Nuclear reactor will having also other components like the this particular turbine. Okay, you will see here the steam will be generated, and that steam will be directly expanded into the turbine. Okay, that is also one type of nuclear power plant. There are different. We can also going to see the classification and the different types of the nuclear power plant. But the basic is that there are basic components are there in the nuclear reactor, and those components are very essential to run this particular nuclear reaction. That is, first of all, a fuel rod, or we can say the fuel element. Then second one is the control rod. Third one is the moderator. Fourth one is the coolant medium or the coolant uh, fluid. And fifth one is the this particular whole casing of that nuclear power plant. Because as that energy will be uh, released by the uranium-235, it will also radiate some harmful rays, okay, or we can say the radiation. And because those are the harmful, because it is in the gamma, those radiation is the gamma radiation, and this will very harmful for the human body. So to protect other equipments from this particular radiation, there is a thick particular concrete wall will be mounted, or we can say the constructed around this particular nuclear reactor, and that particular you will see in this in different pictures and etc. Okay, so that is the function, and that are the components. You can see this is the actual picture of this nuclear power plant. This is the actual core. Okay, and these squares you are going to see. These squares are the nuclear fuel or nuclear rod. Okay, it will contain some very small pellets are there. This particular nuclear rod will contain very small pellets of the nuclear material. Okay, this uranium will be in this type of pellets. Okay, and those pellets are mounted on one another, and it will create one nuclear fuel rod. Okay. Now, why they are this particular uranium, this dimension of this pellet is maximum 2 mm. Okay. So that much small pellet has been manufactured, and those enriched elements will be put into this particular nuclear rod, and then the nuclear reaction will be started. Okay. Those particular spheres you can see, those are the top view of this particular nuclear fuel rods. Okay. These are also, you can see on the right hand side, that is the different fuel rods are there. Okay, it is inserted inside the particular nuclear core. Okay, and there are different factors. This one is known as the connect. This one you will see, these are the rods, control rods, which will control the reaction, nuclear reaction. Okay, so this is the basic construction. Now, it depends upon the its particular construction, we can classify the nuclear power plants or the nuclear reactor into the different forms. Okay, first one is the boiling water reactor. Now, boiling water reactor is a simple type of nuclear reactor in which what will happen? This one is the nuclear core. Nuclear core will consider the nuclear rods, nuclear fuel rods will be there, fuel rods, and also the control rods are there. Now, the difference is that here what will happen, whatever the water is there, it will directly came in contact with the nuclear rod. Okay, and because of that, heat will be generated, liberated from this nuclear reaction. It will be absorbed by this water, and it will convert into the high high temperature steam, or we can say the superheated steam. Now, this superheated steam will be directly going to expand in steam turbine. The main difference or big difference is this: this particular steam, which is directly came in contact with the nuclear fuel rod, it will directly again came in contact or directly going to expand into the steam turbine. Okay, and also after expansion again the condenser will be there, and also the feed water pump will be there. So this arrangement is same or similar to the Rankine cycle or your simple thermal power plant, right? Only instead of boiler, we are using the reactor core or the nuclear reactor core to generate the steam. That only change in the nuclear power plant and in the thermal power plant. Okay, so in boiler water reactor, as the name indicated, the water is itself boiling inside the nuclear core, and it will came in directly contact with the nuclear rod. Now, the main disadvantage of this type of reactors are that when these water particles directly came in contact with the nuclear fuel, because of the radiation, it is the contaminated water. Okay, and when this water or the particular steam will came in contact with the steam turbine, the blades or whatever the components of the steam turbine, those are also going to be contaminated. So if after some time, if you want to carry out the maintenance of this particular steam turbine or this condenser coils or the feed water pump or any other component, we have to take precautions. Now, in many cases, we have to replace this particular steam turbine. So during replacement, we have to take very precaution uh, whenever we're going to maintain this particular steam turbine or the condenser components. Okay, so that is the most important, or we can say the important disadvantages of this boiling water reactor. Also, if the level of water inside this nuclear reactor is goes below the safe level, in that case, explosion may be happen, because whenever we cannot control this nuclear reaction with very high speed. Okay, we cannot totally shut down this nuclear power plant in 1 or 2 hours. It will require days. So in that case, we have to take at most safety levels or safety concerns whenever we install this type of boiling water reactor. Okay, this is the first and simple type of nuclear reactor. Second, you will also heard of this pressurized water reactor. Now here, the change is that instead of directly using this water or whatever the water come in contact with the nuclear rods, we cannot directly expand those water into the turbine. Instead of that, what will happen? We will pass this water through the one heat exchanger. Okay, now here heat will be exchanged. Okay, and that heat will be given to the secondary cycle, or we can say the second circuit of the water. Okay, now this water exchange heat with the second cycle. Here, the whatever the coolant medium or the water will be present inside the heat exchanger, other side of heat exchanger, it will get evaporate, generate the steam, and that steam will be expanded into the turbine. Okay, so instead of directly expanding this particular water or the steam into the turbine, instead of that, we are using one heat exchanger. So whatever the other parts, like the steam turbine, condenser, pump, it will not contaminate it. Now, another difference, big difference in here is that whatever the water present inside this particular first cycle, which is in the nuclear core, it is in at the very high pressure. It is not at the atmospheric pressure. So when we increases the pressure, what will happen? When we increases the pressure, its related saturation temperature will also going to be increases, as we saw in the simple property diagram of the steam. Right? When we increases the pressure, saturation temperature will also going to be increases. So similarly, when we increases the pressure here, or whatever the water present in this particular nuclear reactor, it will be pressurized water. And when we increases the water, pressurize the water, its saturation temperature, or we can say the boiling point of this particular water is going to be increases. Okay, so you will still have the liquid water inside the nuclear reactor, even it will having the temperature above 100 degrees centigrade. Okay, and generally in this type of nuclear reactor, the average temperature inside the nuclear core is, or we can say this first cycle is above 300 degrees centigrade or above 250 degrees centigrade. Okay, so just we are using pressurized water as a moderator and the coolant inside the nuclear reactor. So that is known as the pressurized water reactor. And whatever the water we are using, which is using inside this nuclear reactor, which is came directly in contact with the nuclear reactor, we call this water as a we can say heavy water. Okay, we are considering or we are calling this particular water is heavy water. Okay, so this one is the heavy water, we generally call as heavy water, and it is pressurized. Okay, so its boiling point will be increases. That is the second one. Third one, that is the Kandu type of reactor. This is known as the Canadian Australian nuclear uh, reactor. Okay, so you can see the construction of this type of reactor. Similarly, this one is the main reactor. You will see here. This one is the main reactor. Okay, and this is the first cycle you can see. So this one is the reactor. Here nuclear core you can see where the heat will be generated, Again, this water will be exchanged heat through this particular through this heat exchanger. Now, this the heat will be exchanged to the other second cycle. Here, steam will be generated. This high pressure steam is again passed to the turbine, and the power will be generated. Okay, so that's how this nuclear power plant will work. There are different types, and based upon the requirement, these types are different types of the nuclear power plant are used. We are going to be used. Okay, this is another diagram of the kind of pressure heavy water reactor, pressurized heavy water reactor. Okay, then fast breeder reactor. You will see instead of the water as a moderator or coolant, we are using the liquid sodium. Okay, you will see here the nuclear sodium is used to carry out the cooling purpose. Okay, so now whenever we using the nuclear sodium, okay, one difference is that big difference is there that whenever we using liquid sodium to for the cooling purpose or for the moderation purpose, we cannot uh, we cannot uh, take a water in the second circuit. Okay, because when water and sodium came in contact with each other, the sodium will explode. Okay, that is the basic characteristic of sodium. So avoid any particular accident. We have to install one intermediate loop should be there. Okay, it may be of sodium, other type of sodium. Okay, so it will having intermediate loop, and it is called as a fast breeder reactor. Okay, now the fuel is also different. In this case, it will have in the U35, uranium-235 with the uranium-238 blanket. Now, generally in nature, we will obtain the uranium-235, 238. Okay, and after enriching, we will get the uranium-235. Okay, so these are the different types of the nuclear power plant. Also, you will consider that this one is the difference between nuclear reactor and nuclear bomb. That is the main difference is that in nuclear reactor, whatever the nuclear chain reaction, it is in the under control. Whereas in the nuclear bomb, the nuclear reaction is not in under control. Okay, it is uncontrolled nuclear reaction will be there. Okay, now, in particularly, as we know, whenever we heard any nuclear power plant or the nuclear energy, we just say that nuclear power is very dangerous technology, right? And it is pretty much okay and correct also because the radiation that is the part of nuclear reaction, it is very damaging or hazardous to the human body, even for the plants, even for the soil. So this radiation means what? It is the low, what we can say the uh, low wavelength radiation. As we saw radiation, different types of the radiation. There is a thermal radiation is there, UV rays are there, then the infrared rays, then gamma rays, X-rays are there. Uh, these are the types of radiation. Now, when we plot that radiation on the on particular wavelength diagram, we call it as a spectrum. Okay, lambda. So you will see this type of those hazardous radiation which is having very low wavelength. Okay, means those gamma rays, then the UV rays, then X-rays are there, which are very dangerous to the human body, even for the plants. Now, these will having very low wavelength but very high energy. Okay, and these are also called as a ionized type of radiation, as we saw in the heat transfer. So these ionized type of the radiation which are very dangerous to the human body, even to the plant, even to the soil also. Okay, because it will penetrate through this particular body. Okay, whenever we saw any the different types of the radiation, okay, alpha type of particles or beta particles, those are does not going to damage your skin or does not going to damage the human tissue. But whenever we these gamma rays or X-rays passing through your body, it will because it will contain very high energy, it will damage the cells, okay, cells of the particular organ, and because of that, these are the dangerous to the human body. It is dangerous to the plants and it is also dangerous to the soil. So these are the potential damages, or we can say the disadvantages of the nuclear energy. Okay, first one, that is the hazards of radioactivity, as you already know. Then reactor safety, we have to completely whatever the shell outside, or we can say the casing outside the nuclear power plant. We already saw that it is the concrete wall which is having thickness over 3 to 5 meters. Okay, it is having thickness that much of concrete wall we have to install, because whatever the gamma rays are present inside the nuclear reactor, it must not transport through this particular concrete wall. Okay, which is very dangerous to the human life. Then hierarchy of nuclear waste. Now, whatever after combustion of that nuclear fuel, whatever the waste remains, how to dispose that waste, it is very difficult, because it will contain very high level of radiation. So we cannot directly exhaust that or put that particular waste into the environment. Okay, so to recycling those nuclear waste and dispose those nuclear waste, that is the most important factor, or we can say the disadvantage in the nuclear power plant. Now it is not sustainable, it is also not a renewable, not a renewable type of source of energy, but in the very small amount of fuel will generate very large amount of power. That's why it is very beneficial. Then potential terrorist targets. So these are the some dangerous, or we can say the disadvantages of the nuclear power plant. Now, environmental impact, as we saw, whatever the nuclear waste is there after the consumption of the nuclear rod, to dispose that nuclear waste is very difficult. Then, whenever these suspended particles which are in the environment which came in contact with the that particular disposal from the nuclear power plant, it is it will generate the radioactive release. Okay, or this will generate the radioactive particles. Then environmental impact identified at the very stage of the nuclear fuel reaction, that is from the first of all from mining, then radioactive seepage from the waste and land degradation. So whatever the water coming out from the nuclear reactor, that is also one some radioactive, okay, in the nature. So in that case also we have to uh, properly take the precautions, because the safety is the most important in the nuclear reactor. Okay, so that is also important. Transportation of the enriched, or whatever the nuclear fuel is there, transportation of that nuclear fuel from mining to the nuclear power plant, that is also risk. Uh, that the electricity generation, that is the risk of catastrophic accidents, low and high level radioactive wastage, etc. You already heard of the different accident, nuclear reactor accidents. The first one, that is the Chernobyl accident. Okay, then the Fukushima, which happened in the Japan in 2011. So these are the examples of how much dangerous this nuclear power plants are, because we cannot control the radiation when it mixed with the environment. Okay, you must see some documentary on the Chernobyl. You will understand what is the impact of the radioactivity on environment, on human beings. Okay. Additionally, the decommissioning of the nuclear power plant entails the disposal of nuclear or whatever the radioactive waste is there. Then, while significant technology development has been made in area of radioactive waste disposal and decommissioning, they are yet to be proven at large scale to satisfactorily resolve economic issues. Okay, means we cannot directly exhaust or dispose that radioactive waste to the earth or to the atmosphere. Okay, which is very dangerous. So the most important, or we can say the very big problem in front of nuclear reactors is the nuclear waste. How to dispose, how to recycle this nuclear waste. Okay, so these are the nuclear different environmental impacts. Uh, until now, the India having different nuclear power plants. That is also we are going to see. I will show you the site of Atomic Energy Regulatory Board of India. okay, which is under the government of India. It is under the Department of Atomic Energy. Okay, so you will see the different list of nuclear power plants which are under operation. So this Tarapur having two uh, plants, okay, plant one and plant two, okay, which is commissioner or came in operation in the 1969. So India also having different very large amount of many nuclear power plants are there which are situated at the coastline. Okay, the Tarapur atomic power plant, two power plants are there, which is having 160 megawatt of power, and these are the types of the reactors. Okay, it is known as the boiling water reactor (BWR). Okay, it is a type of the boiling water reactor. Now, also Rajasthan atomic power plant, it is also having two power plants in Kota, Rajasthan, which is having the 100 and 200 megawatts of capacity respectively. And type of nuclear reactor is a pressurized heavy water reactor. Okay, these are called as a pressurized heavy water reactor. And later on, you will see different types of the power plant which are in operation today in India, and their types. Okay, its capacity and their types. This PWR means pressurized water reactor. Okay, so these are the different nuclear reactors which are already installed and already in operation in India. Also, you will see the different safety procedures, emergency preparedness, etc. regarding the nuclear power plant. Okay. Also, you will see different nuclear projects. Okay. These are the different nuclear projects which are under development. Okay. Kakrapar Atomic Power Project, which is in Kakrapar, Gujarat. Also, there is a different nuclear power plant which are in the Haryana, Gorakhpur, Haryana, then in Rajasthan, also in Karnataka, near to Kaiga. Okay. And also, you will see there is one site which is proposed by the Atomic Energy Commission, that is in Maharashtra. Okay, so these are the different nuclear power plants. You will also see the different information regarding the nuclear power plant, radiation facilities, what are the radiation facilities are there regarding the medicine, research, transportation of the radioactive materials. Okay, the transportation, how to transport those radioactive materials, because those are the very high radioactive materials will be there. So transporting, packaging, transporting safely from one point to the another point, it is very important. So radioactive waste management, this is very important. Okay, how we dispose this waste coming out from the nuclear power plant, and different research institutes or the research facilities available. So you will understand the different, or you will get the different information regarding this nuclear power plant on this particular site. Okay. Also, these are the top 10 members which will be using the nuclear energy. You will see the France will having and US will having nearly 104 reactors, which will generate nearly 20% of its electricity or power. France having the maximum percentage of electricity coming out from the nuclear power plant, which is having 58 reactors, but its 80% of power will be generated through the nuclear power plant. Japan is also 25% of electricity or power will be generated. Regarding the India, India having total 18 reactors till 2010, and nearly 3% of electricity or power will be generated by the nuclear power plant in India. Okay, so just it is information. Top 10 countries planning for new nuclear reactors, and you will also see the new nuclear reactors which are going to be unveiled. Now, the one of the sites which is again proposed to construct the nuclear reactor near Jaitapur in Maharashtra. Okay, so that is also you will see the different reactor, different information. And the major nuclear disaster, as we already saw, there is a major nuclear reactor accident or disaster in Chernobyl, which is in the former USSR, Fukushima plant, which is in Japan, which is some earthquake. And because of the earthquake and tsunami, it will cause some disaster. And there is one another nuclear disaster that is the 3 Mile Island. Okay, that is in the USA. So these are the nuclear disasters are there because it will shows you the how the safety is important in the nuclear power plant and why the safety is most important in the nuclear power plant because the scale of this particular accident is very high, but its impact on human body, on environment is very high. Okay, so I will show you one video regarding the nuclear power plant, how they are working. Okay, just this this video. Okay.
A nuclear power plant generates
You will understand how nuclear power plants work in this particular video. Okay.
electricity using the heat released during the fission of uranium atoms. Several types of nuclear reactors exist. The world's most common reactor type is the pressurized water reactor. This power plant has 3 entirely standalone water systems: the primary system, the secondary system, and the cooling system. The fuel used by a nuclear power plant takes the form of small uranium pellets that are stacked in long metal tubes known as fuel rods. These tubes are placed in a steel tank filled with water, the reactor's core. The fission of the uranium atoms heats the tubes, which in turn heat the water to a temperature of 320 degrees. Pressurized to keep it in a liquid state, this water is then channeled to the steam generators. When secondary system water enters into contact with the primary system's pipes, which contain very hot water, it heats up in turn and becomes steam. This steam turns a turbine, which turns a generator. In the generator, the interaction between the electromagnets of the moving rotor and the copper coils of the stationary stator produces an electric current. A transformer then boosts the current's voltage to between 225,000 and 400,000 volts, thereby facilitating transmission over the grid's high voltage power lines. When leaving the turbine, the steam is turned back into water by the cooling system. It is then returned to the steam generator to begin a new cycle. Before it does so, it goes through a condenser. This condenser is either supplied with cold water from the sea or a river, or with water cooled by the draft that circulates in large towers known as water cooling towers. Generating electricity from a nuclear source produces radioactivity and radioactive waste. Facility safety is therefore of utmost importance. The waste is rigorously managed, sorted and treated before being safely stored. Nuclear power plants generate very large amounts of electricity and do not emit greenhouse gases. They are used continuously to meet the growing demand for electricity.
So you will just another just see the another video. So I will share this video link on our group. Okay. So this is regarding the nuclear power plant. It is having different concerns. Okay, whenever we use the nuclear power plant in particular uh, to generate the electricity, and most of the concerns are the safety purpose, safety. Okay, so if you saw the objection which are taken for the whenever we considering the construction of the Etapur project, nuclear power plant. The first one is the nuclear technology is unfit that they saw. Then untested technology, future of fisheries. So whatever the waste coming out from the nuclear power plant is directly going to the ocean. Okay, so the future of fisheries, that is also one of the major problems. And compensation in the case of accident, as we know, the nuclear disaster are the worst type of disaster. Okay, it will having effect on human beings two or three generation, up to two or three generations. It is going to badly affect on the soil. It is also badly affect on the environment. So these objections are very valid whenever we considering to construct any particular nuclear power plant at that particular